So number 7, is it launched from the ground at an angle? So I would go like this. And again, postage stamp diagram people, I would draw it big. Jump. What is the velocity? And what's theta? I would break it up into components. Vy initial, Vx. Hypotenuse, adjacent, oh, color. Adjacent, opposite. Which trig function is Vx going to be? Wait a minute, did it say find the maximum height? I'm gonna do a t-table, but I'm gonna gamble because they're talking about height. I'm really gonna be focusing on the vertical. I can certainly write ay equals negative 9.8. I'm gonna find Vy initial, which trig function? I'm noticing a pattern, Mr. Dewick. Have we spotted it yet? We'll talk about it in today's lesson. There is a cheap hack shortcut I'll show you. But yeah, it's sine. So I think it's going to be, let's go to blue. Vy initial equals 25 sine 35. Whatever the heck that is. You know what? Vy initial equals, I'll just write 25 sine 35, and wherever I need to type that in my calculator, I'll just write that. It's probably about the same number of digits as typing as carrying 5 sig figs anyhow. Okay. I would normally, if they had asked for more, find Vx, but I've already said since they want the maximum height, I'm going to solve vertically. What else do I know? So there's one more key piece that I have to just intuit. I have to deduce. What? What's the vertical velocity at the top for a split second? And I'd like to find that. Looking for an equation that has an A, a VI, a VF, and a D in it. There is one. By the way, I could also find time, but wait a minute. I got 3 things. I can find the 4th. I don't need to find time this time. Which equation? No, I don't know T. I can use VF squared. I can go D equals VF squared minus VI squared all over 2A. So here's what I think I would do because I'm lazy, but I want to be accurate. I would first of all go 25 sine 35, 35. I would get Vy initial stored on my calculator. And then when I type this in, it's going to be 0 squared minus answer button squared divided by bracket 2 times negative 9.8. I'm hoping for a positive answer because I think I am above from where I started. Is the answer 10.5? 10.5 meters. What was that? It's okay. What you're going to find, it takes a while to teach your brain to start to think two-dimensionally in components all the time. Always, okay, don't put a vertical into a horizontal, don't put a horizontal into a vertical. That's why I came up with the T-table just as a way of, you know, literally drawing a wall between horizontal and vertical so I don't accidentally cross them over. And the others from the homework. If you haven't finished the homework, you'll get some time today, but today we're going to build. Last day we did horizontally from a cliff and ground at an angle. Today we're going to do cliff at an angle. We're going to combine both of them. Motion part 2. So some reminders. We said when we launch an object into the air, we call it a projectile. Projectiles travel in a parabolic trajectory. It's one of the reasons you look at the parabola so much in your math classes is it shows up in nature all over the place. We could analyze it, by the way, using your parabola stuff, but it's just way easier to break it into components. By the way, the other way, in answer to your question earlier, Carter, technically the top of the projectile is the vertex. And so you may recall last year you learned how to find the vertex if you were given the quadratic form by rewriting it into parabolic form, completing the square. That's a pain. It's just much easier to break it into components and use physics, but doable. We break each projectile's velocity into vertical and horizontal components. So break the following velocity vector into its vertical and horizontal components. Okay, looks like we're going 24 meters per second at an angle of 36 degrees. I would go like this. D. Call this one Vx. And I would call this one Vy initial. Why do I keep putting the initial on the Y, but not on the X? What am I trying to reinforce? Who remembers? Yeah, Mark. What was that? What's 0? Vy initial is not 0. Might be, but no. What? Vx is constant because Ax is 0. Vy is changing, so the initial will be different from the other velocities. Any chance I get to reinforce that? By the way, color, Mr. Dewick. 24, opposite adjacent or hypotenuse. Are you starting to see why I said at the beginning of this course you're going to get really good at trig? Yeah. Hypotenuse, Vy initial, opposite, Vx. Okay. Vx, which trig function? So I would go like this. Cos. Stop. Let's do a generic one. Instead of writing 36, I'll just put a theta there. That's where the angle would go. Equals Vx over, I'll put the 24 in, but over the slanty V. How would I get the Vx by itself? So Vx ends up being 24 cos theta. Which trig function is Vy? 24 sine theta. Wait. Put your pencils down. Look up. Which trig function was Vy? Which trig function was Vy? Which trig function was Vy? Which trig function was V? Oh, we didn't need to do components here. But when we're doing components for velocities, which trig function is Vy initial? If I was a good teacher, I'd have a dumb, clever way for you to remember that Vy is sine. I'd have something really stupid to help you remember that Vy is sine. And then I'd also have another dumb way for you to remember that Vx is cos. Of course I would. Wouldn't I? You can derive it each time, but as long as that works for the velocity, because I'm always going to give you the velocity from the ground up. I'm always going to put the theta right there. Vy is going to be sine. And then Vx, of course it is. Or if you blank out, you can derive it with opposite adjacent hypotenuse. But hey, let's notice the pattern. And with a minimal amount of memorizing with that stupid gimmick, I think I can remember that and just use the shortcut. Is that okay, Karin? I have your permission? Okay. So let's actually fill in the numbers. So 24 cos 36 is 19.4. If I knew I was using this to find something else, Aiden, I would add some more sig figs. Or I would just type 24 cos 36 later on in the actual equation where the Vx was That's dead accurate. And Vy is sine. 14.1. Carter, are we ever going to use the slanty velocity? No, not once we've done components. So, key ideas. For horizontal motion, Vx is constant. By the way, this little page right here is one of those when you're studying, you want to look at this and say, I have committed or understood all of this, I get this. I guess I'm sort of saying memorize it, but what I'm really saying is understand from what I've taught you of the nature of the universe that this is how it has to work. So Vx is constant because Ax is 0. And Ax is 0 means that Vx is constant. Those both imply each other. That means that d equals Vit plus a half at squared becomes just dx equals Vxt. Yay! This means that if you know the time of flight, you can also find the horizontal distance, the range, or if you know the range, you can find the time of flight. How would I get the t by itself in this equation? By. So again, for the remainder of the year, please stop saying add or divide. And can you actually tell me more specifically? Divide both sides by what? Vx, right? Vertically, Vy changes. Ay is a constant. It's negative 9.8. It's not changing. But because there is an acceleration, Vy is going to change. That's why I always put the little initial there. So d equals Vit is going to be dy equals Viy, t plus a half a. You know what? I should have even put a little y on the a there, t squared. Why don't I put a y on the t? Scalar, who cares? It can go in any equation. Yay. At the top of its arc for a split second, Vy will be 0. Does that mean that the velocity is 0? No. What it means is at the top of its arc, the total velocity just equals the horizontal component for a split second because it's still moving sideways. Is that all right, Connor? Okay. Also, if we start from the ground and end on the ground, Vy initial will be negative Vy final. That can be handy sometimes. Last, if you're beginning from a vertical height from a cliff, the ground is below you, which means dy is going to be negative something. Aiden, you're blinking longer and longer. You going to make it? Okay, I'm going to start to come at you to help you pay attention, okay? Mr. Dueck, yes, Aiden. You said that projectiles travel in a parabola. But I've seen some projectiles that seem to wobble in the air. A bowling ball pin, for example, if I toss it and spin it, Mr. Dueck, or a warped basketball, I've seen those wobble. Are you lying, Mr. Dueck? Put your pencils down, look up. We did horizontally from a cliff. That one was easier. We didn't even have to go components because Vy initial was 0 when you launched from a cliff horizontally. Didn't have to do the trig. Then we did ground at an angle. That was tougher. Did I say angle? We had to go components. The toughest is from cliffs at angles. So to find the flight time for a projectile launched off a cliff at an angle is by far the most difficult. And again, we're going to spend most of our time finding time. There's several strategies. One strategy is find the time to the top, because Vy at the top will be 0. Start at the top, make Vy initial 0, find how long it takes to get to the bottom, and add them up. And you can do that with nothing but Phys 11. Meh. Strategy number 2, do the whole thing all at once and get an answer. Strategy number 3, not recommended. Find the time to the top, double it. That gets you back to the bottom, to the top of the cliff. And then find what Vy is right there, go down with an initial velocity of that Vy and find that time and add this time plus this. I don't recommend that. In fact, I got to be honest. I'm going to do it all at once. But here's the problem. We're going to get a full quadratic, and we're going to have to use the quadratic formula. If you have a quadratic solver, this is where you will be in your glory. This is why I went on my rant last year. Let's do one. I like example one, I like example one, I like example one. Example one is a nice question. Except I won't ask you probably to find A. What's B asking us to find? B. Sesame Street is brought to you today by the letter B. What's B asking us to find? The range. I'm going to have to find time to get the range. Okay. Let's look at this. Aiden, is there a cliff? Aiden, is there a cliff? Ready? I'm coming at you. Is there a cliff? Is this a projectile at an angle? Did I say angle? Components. Okay. First thing I would probably do is just re-sketch this 50 in a little bigger triangle. There's Vx. There's Vy initial. 30 degrees. Is this a projectile? T-table. Horizontal, vertical. I'll change colors just so it stands out a bit. Who remembers what I called my two physics no-brainers that I could write right now without even going to the rest of the question? Yep. Yes. And AY equals negative 9.8. The rest I will adjust to the question. Is there an angle? Did I say angle? Components. Vy. I'd like to find Vy initial and Vx. Vy is what? People. Vy is what? Sine, you say. Very good. So it's going to be 50 sine 30. And I think that actually works out bang even. Check me out. But I think the sine of 30 is 0.5. I think this will work out to exactly 25. Yeah? Sine 30 I've memorized. Okay. Which trig, if Vy is sine, which trig function is Vx going to be? Of course it is. This won't be as nice. Do that in your head, Mr. Well, I know the cosine of 30 is 0.866. Ah, no, I need to do this one. 50 cos 30, 43.301. Yeah, I'll go, the one, there's a 2 next to it. 5 sig figs should give me 3 sig figs of accuracy in my final answer, I think. So 43.301. What else has this picture given me? Sorry? VF? What's VYF? No, when it hits the ground, I assure you, it's not going 0. Do a belly flop right now onto the cement. It's gonna hurt. Bad guess. Be way more obvious. There's a number on the picture we haven't used yet. Huh? Can you just read me the number? Ah, that's 60 meters. So it's a displacement. Is that a vertical or a horizontal displacement? Vertical. So it's going to be a dy, not going to be 60. Negative 60, because I'm ending up below from where I started. You guys are way overcomplicating that. The 60, yes? How many things do I know on the left-hand side in my horizontal column? 2. How many pieces of information do I know on the right-hand side? I'm going to find time vertically. So since A said find time, and trust me, we're going to need to have some room, instead of trying to do it right here in the vertical column, I'm actually going to go A, T equals question mark. And I'm looking for an equation that has a D, a VI, and A, and a T in it. Your hint is, it's the quadratic one. What makes a quadratic a quadratic? It's got a squared. Which equation? Yeah. dy equals vy initial t plus 1/2 8y t squared. Now, Connor, we did do this one last year and find t, but I either had to let that be ay be 0, a be 0, or I had to let v initial be 0. Here, nothing's 0. Nothing's 0. Let's plug in the numbers. We get this. Negative 60 equals 25t. What's half of negative 9.8? Anyone, calculate, whatever. What's half of negative 9.8? Or as most of us say, not backwards talking, are we? Negative 4.9 t squared. What kind of an equation is that? It's a quadratic. How do I know? It's got a squared. How do I solve a quadratic? What's the first thing I have to do before I do anything else? We reviewed this about a week and a half ago, so hoping it's fresh in your brain. What do I have to do first before I even start to solve it? Make it equal to 0, right? Stop, look up. Although the easiest way to make it equal to 0 would be to plus the 60 over, I've learned if I'm going to make a dumb mistake, it's because that's negative. And so I'm actually going to plus that to that side and minus that to that side, because I'm doing it all in my head anyways. Formula manipulation. So I'm going to move the right side stuff over to the left side stuff. And my new equation is going to be positive 4.9t squared, take away 25t, and the negative 60 just drops down like a domino. Also, Aiden, I wrote it in the correct order from biggest degree to smallest, the way you're used to seeing it for a quadratic. Figured may as well do that too. What's A? Yeah? No, the negative 60 just dropped down. It didn't change sides. Remember, and I'm glad you made that mistake, because it is easy to make a sloppy mistake. So you know what we should do, McKenna? Do that, and that lets you know the negative 60 didn't go anywhere. It dropped down like a domino. Yep. This was the equation that I had to avoid with you all last year. Now, there is a workaround where we don't need the quadratic formula. And I'll show you that later in the lesson. But first of all, let's try it with the quadratic formula. What's A in this quadratic equation? I'll put a little A right there, little B right there, little C right there. Normally the quadratic equation is x equals negative b, but since we're solving for t, I'm going to go t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, those of you that have your quadratic solvers, you can write that line there, and you can go straight to the answers. So if you've already done your quadratic solver, have patience while the rest of us poor peasants schlup through this. T is going to be, what would negative b be? positive 25 plus or minus the square root of negative 25 in brackets squared minus 4 times 4.9 times negative 60 all over 2 times 4.9, which is going to be 9.8. I tend to quickly crunch that. Bracket negative 25 close bracket squared minus 4 times 4.9 times negative 60. Inside the square root is 1801. So I would go t equals 25 plus or minus the square root of 1801, all divided by 2 times 4.9. In fact, I might even write 9.8 on the bottom because I can multiply anything by 2 in my head. Here we go. Is this a fraction? Yeah. So more than one thing on the top. Bracket around the top. 25 plus square root. My calculator also opens up a bracket automatically for the square root. 1801. Close off the square root. Close off the top. Divided by bracket 2 times 4.9. You get 6.8814. That there? I'll go 6.8814. Backspace, change the plus sign to a minus sign. Is the other one negative 1.7794? Which one of these will I chuck? Because time can't be negative. In math, these would be your roots or your solutions or your zeros or whatever your teacher called them. In physics, because we're looking at specific applications, we would say, no, that's just along for the ride. So, oh, hang on. Let's report my answer to 3 sig figs. T equals 6.88 seconds. I'll write that as my answer for part A, but if I'm going to use T, I'll use 6.8814. Is that what you got with the solver as well? Okay. Quadratic formula. Who knew it was useful? Notice I left you a lot of room for part A. Notice didn't leave you as much room for part B because you don't need it. Range, horizontal or vertical. So let's just kind of bring our X column over here. We had AX was 0. Wait a minute, do you all still have your T chart on the same page? Like your 2 to a page? Oh, then you don't need to rewrite this. I will, because I don't have it on my screen. You can rewrite it if you want to. What was VX? Sorry? 43.301. Why wouldn't you have the full decimal knowing you're going to use it again? Oh, and now I know time is 6.8814. And I'd like to find dx. Looking for an equation that has a d, an a v, and a t in it. There is one. Which one? Nick, which one? So it starts out as d equals VIT plus a half AT squared, but since a is 0, don't waste my time. It becomes d equals VIT. Oh, wait a minute. Since a is 0, VI is VF is V whatever. And now let's make it horizontal. D equals VXT. Same equation as this one up here, but the horizontal component version. you see why I didn't leave you as much room? You don't need it. It's plug and chug. You have to know what you're doing, though. So Vx was 43.301. T was 6.8814. $297.9, 298. Is that all right? Okay, cool. What else can we handle? Will, what's C asking me to find? Keep reading. Yeah. Why can't I go 6.8814 divided by 2? Because if that's the total time, isn't time to top half the time? This is not a symmetrical path. You have to imagine the path that we're taking. We're going to be going down further than we went up. So unfortunately, that trick that we used from the ground to the ground doesn't work here. Okay. Well, let's make our list. Top. Does that suggest horizontal or vertical? Vertical. So I'm not going to do a full T chart because I don't really have room, but don't you dare give me anything from the X column. What do we know vertically? Oh, physics no-brainer. AY is negative 9.8. And I think I know VY initial. What was it, 25? That's two things. I need three things to find the fourth. What else do I know vertically? Carter. At the top. That's why I'm kind of glad you asked me that question at the beginning of class. Yeah, I know that VY final at the top is 0. In fact, at the top, for a split second, I can tell you exactly how fast it's going. It's traveling sideways at 43.301 meters per second for a split second there. Is that enough to find T? Looking for an equation that has a T, an A, a VI, and a VF in it. There is one. Which one? Are you going to read me an equation that has a D in it? Because I don't know D. Karn. And Karn, I like Karn more than Noah because he even got the T by itself instead of just reading out the generic equation. See, had you tried to get the T by itself, you would have, when you read out your equation, you would, wait a minute, there is no T to get by itself. Which is one of the reasons why I push that as well. VF minus VI over A. So it's going to be 0. By the way, can you see how if you, Carter, didn't know that VY final was 0, kids put all sorts of stuff in there. They typically put VI is 25. They'll often use the 50 because it's bigger and they're desperate, even though you never use the slanty. Or they'll use the 43.301 or something. They'll put a horizontal into a vertical. Don't put a horizontal into a vertical, and that'll take care of 90% of your mistakes. Minus 25 all over negative 9.8. You get 2.55 seconds? Okay. Good. I would consider part B, find the range, a B plus level question. And I'm even going to tell you right now, I guarantee on your test, I'm going to give you cliff at an angle, I'm going to give you the height, say find the range. Why? It does everything that makes my little math nerd heart sing. Oh, do you get to use some Math 11 that you learned in the quadratic formula that you may have thought was useless, but holy smokes is useful? Yeah. Do you have to do some components in it? Yeah. Are you having to do your T-chart and keep your directions and your vectors straight? Yeah. I mean, how much better can you get than that? And it's kind of cool. I like projectile questions. So that one of those is going to be on your test. Okay. Wes, what's D asking me to find? This is an A- level question. Mr. Dewick, isn't the impact velocity, isn't V final the same as it left at? Isn't it going to be 50 meters per second? That would be if the ground was right here. When it gets back to the same height as it started from, it's going to be going down at a 30-degree angle at 50 meters per second. But it's going to keep speeding up, speeding up, speeding up, speeding up, speeding up. What does that mean? Here's what I think the impact velocity looks like. Boom. And you'll notice I didn't do a postage stamp drawing. I'll leave you alone now. No, that's a complete lie. I won't. There's no chance of me leaving you alone. Sorry. I shouldn't make false promises that I have no intention of keeping. Okay. It's going to hit the ground, moving downwards at an angle. Did I say angle? See my thinking? I'm going to break this up into components. The really tricky part is how are you going to draw the triangle? Do the horizontal first, and then do the vertical. Vx. This is not going to be Vy initial. It'll be Vy final, which is not 0. If you're looking for a dumb way to remember the order to draw this, X comes before Y in the alphabet, do Vx, then Vy. And you'll notice when we've always done our components, we've done horizontal, then vertical. That way, all of our angles will be in the same location, and all of our pictures will look the same. And the theta is going to go where the vector is coming from, top left corner. Okay. This right here is the impact velocity, that's slanty. How would I find the magnitude of that slanty? I think I'm going to do Pythagoras eventually. How will I find the theta, shift sine or shift tan or shift cos eventually? Really, what I need to do is fill these two in. I'm good to go. Wait a minute. I know Vx, because Vx never changes. What's Vx? 43.301. Well, that's cool. Turns out I already had done that. Vy final. V what final? Vertical. Let's do a little mini vertical T-chart here. So I know AY was negative 9.8. There was my physics no-brainer. Oh, and I recall Vy initial was 25. I'd like to find Vy final. Do I know anything else that I can put in that column? I could put, don't write this down, dy equals negative 60, was it? Which equation would I use here then if I use that? Vf squared equals Vi squared plus 2AD, and then take the square root when I'm done. The only problem, this is that situation you might recall from last year, when you take the square root, your calculator gives you the positive answer. Pretty sure we want the negative answer. That'll work. Or, what was time? And I could use VF equals VI plus AT, which is easier. The only issue is I'm using an answer to find an answer. I would probably, if it was a test, Carter, use your method. If it was in my homework, I'd go VF equals VI plus AT because I can do that in my sleep. Here, just to check, maybe we'll do both. So really quickly, I'm going to go VF equals VI plus negative 9.8 times 6.8814. We should get V final being negative 42.437, negative 438. Let's just remember that. Let's use Carter's suggestion, which was VF squared equals VI squared plus 2AD. How to get rid of a squared, square root the whole right side. Going to be the square root of 25 squared plus 2 times negative 9.8 times negative 60. I've seen that 1801 somewhere before. That's twigging my brain. Mr. Dewick, when we're doing this, are we actually sort of doing the quadratic formula in steps without realizing it? Yeah. Who knew? Right, that was what was inside the square root before, wasn't it? I think. Do you get 42.438? Oh, look at that. I don't get the negative. Okay, I'll add it in. Have I got lots of, oh good, I still got lots of room. Negative 40, what did I say, Mr. Duke? 42.4382. 4382. And I'll stick that here. 42.4382. Mr. Dewick, why didn't you put the negative in your picture? That's what the down arrow pointing thing means. Now, I need to yell at some of you. As I've been walking around, there's a whole bunch of you that are drawing these pictures, but you're not bothering to put arrows on the end of each line. I'm telling you, you're setting yourself up for dumb mistakes. Put the arrows on the end of each line. It helps you see how it fits together. If I go this way plus that way, that's the same as going that way. Put arrows on the ends of these, please. I gotta erase that without erasing my diagram. Dope! Let's do it this way, Mr. Duke. There. By the way, how big is Vx? How big is Vy? I bet you theta is going to be really close to 45 degrees because this is almost an isosceles triangle. They're almost the same side, not quite. So if I get an answer for theta of like 68 degrees, I've messed up. Yes. Let's find the impact velocity magnitude. Now that's going to be Pythagoras. So that's going to be 43.301 squared plus, answer button squared, square root. 60.6. Am I right? Anybody else? No nods yet? Yeah? 60.6. So V impact equals 60.6 meters per second at. Theta always goes where the vector is coming from, top left in this case. 42.438 Vy, opposite adjacent or hypotenuse. What about Vx? Which trig function? Hey, we're back to good old tan again, which has often been how we found the angle. So tan theta equals opposite 42.4382 over adjacent 43.301 44.4, really close to 45 degrees, which I kind of expected. 44.4 degrees. What of what? Well, if you wrote south of east, I wouldn't take marks off, but I would give you a stink eye, because up is not north and down is not south. We're looking at this from a side view. But if you said south of east, I'd give you full credit. Here's what we've decided as physicists. Because this is a side view, we call this below the horizontal, because it's pointing downwards. If it was pointing upwards, what would I call it? Above the horizontal. So we say, draw a horizontal line. It's an angle of depression, if you recall from my trig lesson way back when, but this is below the horizontal. If you said south of east, I'd give you full marks, but I'm a nerd, I can't say it wrong. When this hits the ground, it's traveling at 60.6 meters per second, and it hits the ground at an angle of 44 degrees below the 44.4 degrees below the horizontal. See why I said cliff at an angle is more work and tougher? Put your pencils down for a second. Example 3. A projectile is launched from a 45-meter high cliff at an angle of 64 degrees with a horizontal. That's my way of saying 64 degrees above the horizontal. Did I skip example 2? Well, let's do example 2 then. Whoops. Oh, I gave you a picture. I like example 2. I like example. This is what I'll probably ask on a test. I'll give you cliff at an angle, and I'll say find the range. By the way, if I give you a cliff at an angle, if I give you the range and say find the height, way easier. We'll do one like that. But here I'm giving you the height and saying find the range. Okay. What's my strategy going to be? Well, it's a projectile. So T-table. Physics no-brainers. AX equals AY equals. Good. The rest we adjust. Did I say angle? Components. Well, okay. Vy initial. Vy sine? Really? Going to be 35 sine 20. By the way, that Vy is sine and Vx, of course it is. That works for velocities, projectiles. Doesn't work for airplane crosswind. Doesn't work for boat going across river. So you got to do the trig there, but dumb shortcut here that works. 11.9707. Well, if Vy is sine, which trig function do you think Vx is? Of course it is. $32.889. $8.892 if I carry one extra sig fig. Alrighty. How many things do I have in the left-hand column right now? 2. How many things do I know in the right-hand column? 2. Okay, what else has the picture given me? No, it hasn't given me 20 meters. It's given me negative 20 for vertical. Which column do I have 3 things in? Because I asked you to. Sorry, I didn't even think about that. That was almost a reflex right there. Vertical, and I can find time. Which equation am I going to use to find time? It's got an A, a VI, a D, and a T in it. Now, I'd like you to do me a favor. Draw a line down the middle of your page. About 2/3 of the way. I'll show you if you're a little shaky on the quadratic formula. First of all, how many of you have a solver? This whole half of the room? Oh, and then, okay. Okay, I'm going to take that back. If you drew the line, that's fine. I was going to show you a workaround that doesn't require the quadratic formula. Here's what I'll say. If you want to work around, hit me up either tomorrow during Blended via Zoom, or hit me up during a Y block when we're all together, or you can hit me up after school today or something. I can show you there is a workaround that does not require the quadratic formula. Your hint is you find Vy final first, and then you can use that to find time. But since a bunch of you got the solver, and I think some of you have said you're okay with the quadratic, let's do that. Which equation? Is it the d equals VIT plus a half AT? Yeah. D equals VIT plus a half AT squared. D was -20. Vy initial was 11.9707. T plus a half A. What's a half of -9.8? -4.9? Or some of us like to say 4.9 negative, backward speaking, are we? Karin, what kind of an equation is this? It's a quadratic. How do I know? It's got a squared. Before I even start, what do I have to do? Make it equal to, I'm going to go, McKenna, move that over and move that over. So my new improved equation is going to be positive 4.9 t squared, take away 11.9707 t minus 20 equals 0. That's A, that's B, that's C. By the way, the question said find the range, which we haven't even got to yet. We got to find time. We're going to spend most of our time finding time. Oh. T equals -b plus or minus the square root of b squared minus 4ac all over 2a. T is going to be positive 11.9707 plus or minus the square root of, I'm running out of room here. Okay. Negative 11.9707 squared minus 4 times 4.9 times -20. I've got to cross the line there. All over. Hey, what is 2a? What is 2 times 4.9? You know what? I'll put the 9.8 there because that's a nice familiar number. I'm going to figure out what's inside the square root first. Bracket negative 11.9707 squared minus 4 times 4.9 times -20. Ugh. Square root of that. I'll go 23.1365. I think is what the square root worked out to. I could have tried leaving this inside the square root, but I saw all those decimals. I'm going to be rounding off here no matter what. So I figured, okay, I'll do the square root now. So I got 23.1365, 23.1365. I got this. T is going to equal 11.9707 plus or minus 23.1365 all over 9.8. I'm not going to worry about trying to use my answer button all over the place here. If you have the built-in solver, great, you'll be more accurate than I will be. But because I've carried 5 or 6 sig figs, I'm pretty sure when I find t, it's going to be good to 3 or 4 sig figs. Good enough. So I get a t value of 11.9707 plus 23.1365 divided by 9.8. Those of you with the solvers, did you get 3.58 something? 3.582? 3.5823? Does my 6 match your 6? Because this is rounded up. Does my 7 match yours with the solver?
Yes, I have 7.405.
Okay, so I'm actually good to about 7 sig figs, right? I'll take that. So 3.58237. 3.58237. 3.58237. I would also get a negative time of negative 1.139, which I would chuck. If you don't write the negative time down, I'm not going to freak out, but I just do for symmetry. By the way, this negative 1.139 does have a meaning. Look up. If instead of traveling this way at 35 meters per second at a 20-degree angle above the horizontal, if it was traveling this way at 20 degrees below the horizontal, and if it could somehow go into the ground, it would hit down here 1.139 seconds later. In other words, if it was starting from the ground, it would have had to have started 1.139 seconds ago to get to this place at this particular velocity. So it does mean something, but whatever. We're done. No, we're not. It's not even what they asked us to find. Josh, what did they ask us to find? The range. We'll figure out when I'm making eye contact with that one, but that's okay. I'll make eye contact with you. Range. Horizontal or vertical? You know what? To find the range, that's going to be technically plus a half AT squared, but why didn't I bother writing plus a half AT squared horizontally? What's my acceleration? Oh. What was Vx? I've scrolled down. 32.8892. And time was 3.58237. $118. And again, what's that telling me? It's telling me it hit the ground 118 meters from the base of the cliff. That's the range. Okay. That to me is a good written question on your test. Be worth 7 marks. Can you see how I can give out lots of part marks? Because holy smokes, we've gone well beyond Physics 11 where it was plug and chug one step. This was, well, 1, 2, 3, 4, at least 5 steps involved and a bit more. Lots of recognition as well. This is Physics 12. Is that okay? Yeah? By the way, again, Karn, all of you, especially those that are athletes, you do this in your head. I can throw something at a fairly high arc and you can glance at it, run to where it's going to be. You can calculate the range intuitively and you can be waiting there when it gets to you. It's pretty impressive what our brains can do. Example 3. In the interest of time, I'm going to pass example 3. Skip example 3, and I'm going to go to example 4. I'll probably do example 3 next class as kind of a warm-up, maybe. Example 4, I like example 4. I like example 4. I like example 4. What if the projectile is launched from a cliff horizontally? Well, let's dollop over here. If we're launched horizontally from a cliff, let's say, I'll make this up, 30 meters per second, just making up numbers. What's Vx exactly? 30. What's Vy initial exactly if we're launched horizontally from a cliff? 0. Which makes it way easier. Don't need to do components. Well, I did technically, but I didn't need to do trig. Okay? So if you're launched horizontally from a cliff, oh, and by now you've done enough physics to know anytime something is a 0, it makes the math much nicer. So Vy initial would be 0. Okay? Example 5. Actually, this is an easy question. It's going to fall apart. Can you see why I was able to glance at this and say it's going to fall apart? What do we spend most of our time finding? Look at the question. It gave me the time. That means I've already got something that can go in both columns. I'm still good at t-table and components. I see an angle. But I don't think I'm pulling out the quadratic formula here. So here is another nice projectile cliff question if I want to save you some time on a test or a quiz or something like that. Nick, what's A asking me to find? Okay. Well, did I say angle? Components. What are my physics no-brainers? AX equals AY equals negative 9.8. Vy, is this horizontally from a cliff? Is Vy initial 0? Nope, there's an angle. Vy, really? Sine? It's going to be 20 sine 30. I think that's going to work out evenly. Double check me, but doesn't it work out to exactly 10? Yay. Vx, well, if Vy is sine, which trig function is Vx? Of course it is. I might be able to do that in my head. It's going to be 16 plus 1, 17.82? 17 point what? 32? I carried the 1 wrong. Okay. You know what? Let's do that, Mr. Do It, because I don't trust you guys. $17.3. You're right. 17.32. Oh, and everybody, look up. T equals 5.2. T equals 5.2. How many things do I have in the left-hand column, in the horizontal column? I can find a fourth. How many things do I have in the right-hand column? I can find a fourth. This question's going to fall apart. What did you say the first thing they were going to ask me to find, Nick, was? Height? Height, vertical or horizontal? Okay, so I'll even do part A underneath part A. dy equals, looking for an equation that has an A, a V, a T, and a D. Are you starting to notice which equation we're using by far the most when it comes to projectile motion? The quadratic one. D equals VIT plus a half AT squared. So dy equals Vy initial T plus a half AY T squared. Oh, howdy.
Does that work?
Pardon me?
Is there? I know we have our 11:45 Y block. Is there a better time to come and do a quick instruction for 12?
You can come right now.
No, you're in the middle of teaching. I just
They can handle the distraction. You're here.
Can you?
Hey, this is nice. Because the D's already by itself. This is straight plug and chug. The height of the cliff is going to be 10 times 5.2 plus 0.5 times negative 9.8 times 5.2 squared. If you type this into your calculator, Josh, you already typed it in? Or are you showing something else? Okay. You get a bit of a weird what are you noticing? This is a displacement equation. It's going to give you the displacement. Did you end up above or below from where you started? I should get a negative. That's not going to make me stress. That's going to make me go, I probably did this right. By the way, the beauty of this equation, because it's a displacement equation, this equation is taking into account the fact that you went up and then came down. It's actually just calculating that distance there. It's taking into account the fact that you went up and came back. It's all in the equation. Don't need to do any compensating or anything like that. It's straight plug and chug. What did you get? Negative. Josh, what'd you get? 80.49, so 80.5? Yes? Is that right? 80.5? It's Josh. Yeah? Oh, got it. Good. 80.5 meters. Okay. So that was A. B. What does B want me to find? It's in front of you, those of you that are looking up. Huh? dx, the range? Wasn't that one vxt? Plus a half at squared. Oh, what's A? I'm going to encourage you, don't even write the half at squared. I've lost track, Nick, how many times I've seen kids do this and then put the 9.8 in there because they're just so used to putting a 9.8 in for A. And that's why you were, I think, the first group last year that I started to do that don't waste my time little routine on purpose to say, hey, don't even write stuff down if you know it's a 0. Let's remove that mistake that we might accidentally do later on. Vx was 17.72, sorry, 0.32. Time was 5.2. You'll notice basically 3 or 4 lines for this question as opposed to many more lines for this. If you have the time, the question's going to fall apart if they give you time. What'd you get? 90? 91? 90.1 meters. Positive answer because I guess to the right is positive. Sure, that works. Is that all right? Cool. Well, that was easier. Wow, I left a lot of room for that. I always forget. I've got an extra blank page in here. I need to remove that. Oh, is there a part C? Oh, there's a part C. Ah, that's why I left a blank page. What is the final velocity of the projectile just before impact? What is it not?
0.
Not 0. Do a belly flop onto the cement if you don't believe me. So, part C, DAP, DULP. Yeah, I guess DAP would work, but DULP, draw a little picture, but not posted, stamp sized. Okay. I don't know who it is. There's going to be some, every year, there's some kid who's like, oh, there's V final. And there's my components. And you just made it so much more difficult to see things. So I'm going to argue that when we hit the ground, we're traveling like that. Now, it's possible that we're traveling like that, not as steep, or it's possible that we're traveling really steep. So I kind of do a generic one-ish. This is V impact. V imp. You could call it V final as well, but I'm going to have a VY final later on, and I don't want to confuse myself. It's hitting the ground at an angle. Did I say angle? I'm going to do the X first and then the Y. One of these I know already. Which one is constant and unchanging? 17 point, what was it? 3 what? 3.2? Did I go to more sig figs than that, or just that? Okay. Must have been a 0 after the 2. Vy final, not 10. And not 20. Those are the 2 most common mistakes. We have to calculate it. I usually just do a little vertical t-table right here. Vy initial was 10, was it not? Yes? And, oh, my physics no-brainer, negative 9.8. That's 2 things. I need 3 things to find the 4th. 5.2. By the way, I could also use Josh's distance of negative whatever it was, but they gave me the 5.2. I can definitely get V final by itself. I'm looking for an equation that has V final, V initial, A, and T in it. It's our old friend, the first one. And the nice thing is the Vy final, the V final is already by itself. So Vy final equals Vy initial plus AT. Oh, plus AY T. By the way, which way are we traveling when we hit the ground vertically, up or down? Am I expecting a positive or a negative answer here? Ooh, okay. But look up. I could have asked you to find the velocity, let's say when we were right there. I could have said, find the velocity after 1.2 seconds instead of 5.2. There, I might get a positive Vy, and that tells me, ooh, I'm still on the way up. Okay, it's doable. But I'd have to give you the time. What'd you get? Can you give it to me to as many sig figs as possible, since I'm going to use this to find another answer? Negative 40.96. And that's going to go in my diagram. I'm not going to include the negative on my diagram because the down arrow is the negative. How can I find the magnitude of the impact velocity? How can I find the magnitude of the impact velocity? Pythagoras. Yeah, I was going to say I'm looking for a word that starts with the letter P and rhymes with Pythagoras, but yeah, Pythagoras. So the magnitude, it's going to be 17.32 squared plus 40.96 squared, square root. $44.4713, 44.5. Oh, final answer, Wes. Now I'll round off to 3 sig figs. 44.5 meters per second at, where's the theta going to go? Top left or bottom right? Where the vector is coming from, always. So, top left. Color, 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 color. 40.96, opposite, adjacent, or hypotenuse. $17.32. Which trig function? Tan, you say. Tan theta is opposite over adjacent. Shift tan of 40.96 divided by 17.32. Q. Did I type that right? 40.96. Wow, that's what I missed. The 0 didn't show up. 40.96 over 17.32. Do you get 67.1 degrees? What of what? Below the horizontal, if you want to sound like a nerd. Okay. If you said south of east, I would give you credit, but I'd probably write a little frowny face next to there and just go, that's not up. That's not down. Yeah, below the horizontal. Or above the horizontal. Pardon me? It's typically, we use the horizon as our reference. But yeah, you could use a vertical frame of reference as well. This is what we went with. I'm going to pick up with this on Thursday because I want to give you some practice on this. By the way, technically, I'm done. I'm not going to be teaching you anything new for the remainder of the lesson. I'm just going to be showing you clever ways to use this. But if you want to get a head start on the homework right now, you can try number 1. I would do these on a separate piece of paper. Okay. So number 1 is 4 projectiles getting launched at an angle from different heights. Find the time of flight, find the range. Each one of those is going to be a quadratic. Not wild about number 2. Number 3, it's asking you to find the resultant velocity. It's asking you to find the impact velocity like we just did. It's a tricky one. 6 is good. 7 is good. So right now I assigned 1, 3, 6, and 7. Technically, you can do every question in the ultimate review, but there's some nasties in there that I haven't talked about that I'll talk about on Thursday. I've talked a long time.